Finding the terms of a sequence. Rule or formula. General term. Frequently, a sequence has a definite pattern that can be expressed by a rule or formula. In simple sequence 2, 4, 6, 8, 10, we know that 2 is the first term, 4 is the second term, 6 is the third term, 8 is the fourth term, and 10 is the fifth term. Each term is paired with a natural number by the rule of a sub n is equal to 2n, or a sub n equals to n. See this a and n. We can read that as a sub n because n is a subscript of a. Hence, the sequence can be written as 2, 4, 6, 8, 10. Since the 2 is our first term, we have a symbol for that, namely a sub 1. The second term is a sub 2, the third term is a sub 3, the fourth term is a sub 4, and so on. If we are referring to the 100 term, then we can have a symbol of a sub 100 for that. If we are referring to the 50th term, so we can have a symbol of a sub 50. See how we just substitute the number of places to n if we're referring to that number. So if we are referring to the nth term, then we just called it a sub n. Now let's try to see if this is really the formula for this sequence. Again, we try to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. We know that the formula is a sub n is equals to 2n. We just need to substitute 1 to n in order for us to get the first term. So we have 2 multiplied by 1, and because the value of n here is 1, so we just change n into 1. So 2 times 1 is equal to 2. Now in this case, on the second term, the value of n here is 2. So a sub 2 is equal to 2 multiplied by 2, and that is 4. On the third term, since 3 is the value of n, we just substitute 3 to n. So that is 2 multiplied by 3 is equals to 6. On the fourth term, or a sub 4, we just substitute 4 to n again. So that is 2 multiplied by 4, that is 8. A sub 5 is equal to 2 multiplied by 5, because 5 is the value of n, and that is 10. See how we get the term because of this formula. Now, if I'm going to ask you, what is the 50th term of this sequence? So all you have to do is to write a sub 50. And remember that you substitute 50 to n. So that is, considering this formula, 2 multiplied by 50. So that is the 50th term is 100. Let's try this example. Find the first 5 terms of a sequence that is denoted with the formula a sub n is equals to 3n plus 2. Let's first compute for the first term. Remember, if we need to find the first 5 terms, 2, 3. We know that the first term is a sub 1, the second term is a sub 2, the third term is a sub 3, the fourth term is a sub 4, and the fifth term is a sub 5. We just need to compute for the values of the following. Let us start with a sub 1. A sub 1 is equal to 3 multiplied by 1 plus 2. Because 1 is the value of n, that's why we change this n into the value of n here. So that is a sub 1 is equal to 3 multiplied by 1 plus 2. We're going to simplify that. We have 3 plus 2, or a sub 1 is equal to 5. For a sub 2 is equal to 3 multiplied by 2. Again, if the value of n here is 2, we just substitute the value of n to the formula. Then we simplify that. A sub 2 is equal to 6 plus 2. Or a sub 2 is equal to 8. For a sub 3, 3 multiplied by 3 plus 2. That is a sub 3 equals 9 plus 2. 9 plus 2 is 11. So the third term is 11. A sub 4 is equal to 3 multiplied by 4 plus 2. So that is 12 plus 2. That is 14. For the fifth term, a sub 5 is equal to 3 times 5 plus 2. That is 15. Plus 2 is 17. Therefore, this formula can form the first 5 terms of this formula is 5, 8, 11, 14, and 17. Now let's try to solve the following examples. Let's go with the first examples. Find the first 4 terms of a sequence whose general term is a sub n equals 2n minus 1. Again, if we are asked to find the first 4 terms, the first 4 terms are a sub 1, a sub 2, a sub 3, and a sub 4. Now the formula is, let's solve for a sub 1 first. So we have the formula a sub n is equal to 2n minus 1. Now let's solve for a sub 1. A sub 1 is equal to 2 multiplied by 1 minus 1. See how I change n into 1 to have this formula? So we have 2 minus 1. So a sub 1 is equal to 1. So this is our first term. Again, let's solve for a sub 2. A sub n, the general formula, equals 2n minus 1. So we have a sub 2, the second term, is equal to 2 times 2 minus 1. So that is 4 minus 1. So a sub 2 is 3. Now let's solve for a sub 3, or the third term. A sub n equals 2n minus 1. So we have a sub 3 is equal to 2 multiplied by 3 minus 1. 2 multiplied by 3 is 6 minus 1. So we have a sub 3 is equal to 5. So this is our third term. And for our fourth term, just copy again the formula. A sub n is equal to 2n minus 1. So let's solve for the fourth term. That is a sub 4 equals 2 multiplied by 4 minus 1. So that is 8 minus 1. So a sub 4 is equal to 7. Now the first 4 term for the given general formula are 1, 3, 5, and 7. Let's go to the second example. Write the first 4 terms of the sequence defined by a sub n equals 1 over n. So again, the first 4 terms are a sub 1, a sub 2, a sub 3, and a sub 4. Again, I would like to remind you that this formula is unique in every sequence. Every sequence has a different general formula or rules to follow. Now let's solve for a sub 1. We have a sub n equals 1 over n plus 1. Now let's solve for a sub 1. A sub 1 is equal to 1 over 1 plus 1. 1 because the value, this n becomes 1 because the value of our n is 1. So therefore, a sub 1 is equal to 1 half. That is the answer. Now let's solve for a sub 2. Copy the formula. Then we have a sub 2 is equal to 1 over 2 plus 1. We have a sub 2 is equal to 1 over 3. So that is the general for that is the second term. Now let's go to the third term. That is a sub n equals 1 over n minus 1. So a sub 3, the third term, is equal to 1 over 3. Well, it should be plus, not minus. Plus 1. So we have a sub 3 is 1 over 4. Now for the fourth term, just copy the formula a sub n equals 1 over n plus 1. So we have here a sub 4 equals 1 over 4 plus 1. So a sub 4 is 1 over 5. So our first four terms are 1 half, 1 third, 1 fourth, and 1 over 5. Let's go to the last example. For the third example, we are asked to find the first 5 terms of the sequence defined by a sub n is equal to negative 1 raised to n all over 2 raised to n. Be mindful of this. The values of n or the variable n is placed in the exponent of negative 1 and 2. So therefore, we need to have our patience and we need to focus on how to do it. Do not make mistake of making 2 multiplied to n. It is raised to n. Now again, let's solve for the first term. So we have a sub n equals negative 1 raised to n over 2 raised to n. So we need to solve for a sub 1. So a sub 1 is equal to negative 1 raised to 1 all over 2 raised to 1. So our a sub 1 is negative 1 raised to 1 is negative 1 all over 2. So that is negative 1 half. For the second term, let's copy again the formula. Negative 1 raised to n all over 2 raised to n. We have a sub 2 equals negative 1 raised to 2 over 2 raised to 2. Again, we change the exponent into 2 because n is the exponent. So we have a sub 2 equals negative 1 squared is positive 1. Remember, if you multiply the same sign, you get a positive sign as a product. So we have 2 raised to 2 is 4. So we have positive 1/4. Now let's go to the third term. The third term, again, let's just copy the formula first. Negative 1 raised to n over 2 raised to n. A sub 3 is equal to negative 1 raised to 3 over 2 raised to 3. So a sub 3 is equal to negative 1 raised to 3 is the same with negative 1 times negative 1, that is positive 1, and multiply again to negative 1. So that is negative 1 all over 2 raised to 3 is 8. So negative 1/8. Okay? Now, for the fourth term, again, let's copy the formula for our reference. Negative 1 raised to n over 2 raised to n. So we have a sub 4 equals negative 1 raised to 4, negative 1 raised to 4 over 2 raised to 4. So a sub 4 is equal to negative 1 raised to 4. If a negative number is raised into even number, then the answer is positive. So this is positive 1. So we have 2 raised to 4 is 16. So we have a sub 4 is positive 1 over 16. I have small space here. Let's try to fit in a sub 5 here. So again, a sub n is equal to negative 1 raised to n over 2 raised to n. So a sub 5 is equal to negative 1 raised to 5 over 2 raised to 5. Again, if a negative number is raised into an odd number, the answer is negative. So negative 1 over 2 raised to 5 is 32. So our fifth term is negative 1 over 32. So that is the answer for here. We have negative 1 half, 1/4, negative 1/8, 1/16, and negative 1 over 32. So these are the first 5 terms of this sequence, this general term. Now, this is a different kind of problem. We are not asked to find the first 5 terms or the first 4 terms. Instead, we are asked to find the 13th term and the 100th term use of this sequence whose formula is given by a sub n is equals to 2n minus 1. Now, let's try to compute first the 13th term. Remember the formula. A sub n is equal to 2n minus 1. Again, remember, if we're going to find the 13th term, that is equal to a sub 13. Since we change n into 13, the value of our n is 13. So 2 raised multiplied by 13 minus 1. So the 13th term is 2 times 13 is 26 minus 1. So a sub 13 is 25. So that is our 13th term. Now let's solve for the 100th term. So we have a sub n equals 2n minus 1. So again, if we're looking for 100th term, we are referring to a sub 100. Now let's change n into 100 minus 1. So a sub 100 is equal to 200 minus 1. So the 100th term, or a sub 100, is equal to 199. So that's how easy it is. Thank you everyone for listening. Hope you learned something from this video. Bye-bye.